This is our homework for lesson 53. We're going to plug in the unit now and it'll give us a prompt to take our first measurement. And we're going to take our first measurement at 100 centimeters. Line it up as close as we can to 100 centimeters. It's prompting us to take the reading. We'll take the reading. 99.9 centimeters. Okay, that's close. And we'll go to 90 centimeters. Take another reading. Okay, here we are at 90 centimeters. Let's take another reading. It's prompting us to. Red button. 89.7 centimeters. Okay. Within about 0.3. It's not, well, maybe it's not quite at 90, so that's a good reading. And we'll just go to 80, and that should complete the demonstration. Okay, we're hitting on 80 centimeters. Let's press the red button. We have the prompt. And 79.9, close. Okay. Let's go through the code. First, we have some include statements. The first is a wire for the LED display and the BME 680. Actual display actually does do an SPI and a I2C interface incorporated in that unit, but we're going to be using the I2C, so we call up the wire library. The Adafruit sensor library, the Adafruit BME 680, which is going to give us our temperature and humidity readings for the calculation of the speed of sound. The Adafruit graphics library for our LED display 1306. And we're going to declare some variables, the trigger pin, echo pin. We have a variable for the BME. It'll also give you the altitude if you give it an altimeter setting. And we have the interrupt pin. It's going to be pin 3. And we have the take reading. When that's true, we're going to be taking readings, distance readings. The distance val, pulse timing, and humidity temperature variables. Then we have the BME sea level pressure. We convert it from the reading that we have here in inches of mercury to millibars. We have the 1306 display. It's a 128 by 64, and this is where we designate we're going to use the quick connector daisy chain with the BME. And the only thing you do differently is that instead of just wire, it's wire 1. That means we're going off the quick connector. Then we go into the setup, set the baud rate. Then we initialize the begin of our monitor, our 1306, and it's at address 3D. Then we do an output, pin mode output for the trigger pin. Then we have, it's going to check the BME and make sure it's actually installed. It can talk to the program. If not, it gives us this error message. Then we go down to some sampling and initiations for the BME. Then we have our interrupt that's going to check for our switch. When we press the switch on the falling edge from high to low, it's going to initiate this functions switch press, and that switch press is going to cause this to go true, the take reading, and we'll take a reading. Then we're prompted here, function call. This is the startup prompt. It'll give us prompt us to take our first reading. Then we go into the loop, small loop, very tight loop right there. We're going to delay a second to let the BME do its thing and take a temperature and humidity reading. Then we're going to make some function calls, get temp, humidity. We're going to calculate the range. We're going to print to the monitor, the serial monitor. Then we're going to check if the button has been pressed. This will be true, and then it'll take our next reading. Then these are our function calls. These are our functions. We have the get temp humidity function, the print to the serial monitor, the calculate range, where we use the speed of sound here in this calculation. And the BME is going to give us this temperature and humidity. Then we have the print to OLED or LED display. Then we have the startup function. This will give us our startup prompt, prompting us to take our first measurement on startup. And the interrupt routine. And what it's going to do is assign true to the take reading.